One consequence of relativity is that clocks run more slowly for an object that moves with velocity relative to the reference frame of the observer, as defined by special relativity. Considering gravitational fields, space-time curvature, as defined by general relativity, implies that the clock runs more slowly the closer to the source of the gravitational field. Relativity is applied, for example, to GPS technology, where the satellite clocks are moving at 14,000 km per hour comparing to clocks on the surface of the Earth, so that satellite clocks tick more slowly, by about 7 microseconds per day. Those satellite clocks are 20,000 km above the Earth, so tick 45 microseconds per day faster, due to the gravitational field, than the corresponding on the surface of the Earth. The net result, velocity and gravitational field, is GPS satellite clocks advances about 38 microseconds per day faster than on the ground. GPS satellite clocks do have an accuracy of about 10 to the -9. In recent years, technological advancements have allowed to develop atomic clocks with accuracy up to 10 to the -18. In 2013 the record was established with accurate to within 1 second every 300 million years. In 2017 the record was established with an atomic clock that won't lose or gain a second in 15 billion years. Increasing accuracy of atomic clocks makes it a possible method to test relativity. I have been developing a hypothesis concerning gravity, adding an additional condition to the relativity equations. That hypothesis shows discrepancies, considering the proper time, with respect of the Standard Model of Relativity by about 10 to the -20, for the Earth's gravitational field, at the vicinity of the Earth, and about 10 to the -15, for the Sun's gravitational field. This would be the discrepancy if a distance from the Sun similar to the Mercury orbit is considered. It is proposed a project to develop a viable method to test relativity using atomic clocks. The aim of the project is to define the best method, taking into account current technology available, costs and accuracy of the measurement that will be obtained. The hypothesis proposes a quantum time process in which the mass energy changes from an alpha state to a beta state, the EFE, or better said, the space-time distortion which is defined by a mathematical model like the established by the Einstein's field equations, is the consequence of that alteration. This way it is established an interrelation between the proposed process and the distortion of spacetime. The EFE allow us to know the probability of the proposed process taking place for any given coordinate, so that the EFE are giving us information at the quantum level. Interaction between gravitational waves and mass energy changes the state of mass energy from alpha state to beta state, reducing the quantity of mass energy in alpha state. That is the reason for the space distortion, the distortion of time which is linked to an increase in the number of statistical trials, restores the value of the mass energy in alpha state, but now in a curved space-time. If the hypothesis is a correct one, would have important implications in various areas of science and its effect would be decisive in the study of black holes or issues related to cosmology.